Well, thank you. Yes, your responses, and I checked all of those comments, and we may have missed a few points. Not a whole bunch, but we did miss a few points that we're going to clear up today. We decided to do a follow-up video immediately instead of waiting a while. Just kind of explain some more finer points of this without going into too much great detail. Polishing, filtering. Well, on to the follow-up here for the polishing and filtering video that we did yesterday. God, I love the response and the results back from the community. You guys are awesome. I read a bunch. I was up late last night reading comments and trying to address some of the more prominent ones right off the bat. But let's start off with, all spirits do not require filtering. Why would you filter something that comes out great? Well, that's sort of like an age-old question. Sometimes we get this idea someone like me will come along and show you how to filter and claim that it's the latest and greatest or it's next to exceptional and you need to do that, and then all of a sudden you think you have to filter everything that you make, and that's not necessarily the case. I have often said if you run a still correctly, and depending on what you're trying to make, depending on what your grain bill was, filtering is probably, in a lot of cases, is not in your alley because of the product that you're trying to produce. Let's take, for instance, a pot still, and you're trying to make a really, really good bourbon or whiskey. You want to make sure that all those flavors are imparted that are in your spirit remain there. So I guess the first question to answer is, will filtering remove some flavors? Well, if those flavors are part of your ethanol, no. But if a majority and a concentration of those flavors are resident in some of those other substances that are filtered out, well then, yes. And you may not notice any difference. But the point is that will filtering, I guess the answer to the question is, will filtering remove flavor? In some cases, yes, and in some cases, no. That's about the easiest way to explain that, because you have to look at this stuff on a molecular level and what flavor actually is. Flavor is not specifically a molecule within itself. More or less, it's the arrangement of that molecule and the way your taste buds pick up and react to that presence of that chemical. Now, if you're using extracts, of course, some of them are artificial and they are molecules of some sort, of some chemical component. So yes, those will be stripped out or could be stripped out. And again, it depends on their size. Oh, see, there are so many maybes, and I wish I had a direct, down and dirty, yes, this is, no, this isn't, but it's just not the case. So now, what's a spirit off the top of your head? What's one spirit you know that is going to be filtered? Vodka. Yes, vodka. The age-old pure. They call it a neutral spirit. It's just high in alcohol content and really has no flavor profile. Bottom line. That is just to say it simply. So those are your vodkas. But the vodkas do have a flavor profile in general based on what they're made from. If they're a wheat-based, if they're an oat-based, or if they're sugar-based. Oh, you see how this can get so enormous, the understanding of it, but it's relatively simple. Most of the time, a vodka should be filtered in order to make it pure. Okay, some gins, if you're going to infuse flavors after, like the video we did on making your own gin infusions, some whiskeys, and it all depends. And again, a lot has to do with personal choice. So there we go with that. We've got that one answered. Hey, if you get a chance, please, of course, subscribe. I shouldn't have to say that. And what I'm going to show you is we're going to start to put this thing together, and I'm going to show you how I put it together real briefly. But I've got something else to share with you, and that is a little bit more in depth for some of us geekoids, I guess you would call us, that like to understand the nitnoids about certain things. I'm going to share that with you. But I wanted to answer a couple of other questions while I'm doing that. And the one is I had someone write in just say, yeah, look, I really understand why it should be a wet carbon that goes inside your filter. I understand that, but can you tell me why? And yeah, quite simply, I can tell you why. Let's stop and think about this. Remember, we don't use a dry carbon. And why is that? And if we do use a wet carbon, we don't want any air pockets. So what's the easiest way to displace air and air pockets in your carbon filter? Well, that is to use water, yes, to push all that air out. And so therefore, when you're running your spirits through, you have no air pockets in which your spirits will start to maneuver around, and they will miss your charcoal and therefore not be filtered. I mean, that's why it's done that way. And also using a liquid, which is the water, will cause it also to pack in a little bit tighter, so it becomes a little bit more effective. So that's why we use a wetted carbon as opposed to a dry carbon, because we want to avoid any air spaces or air pockets that could develop in your carbon. Okay? Oh, good. I got that one. One other that was written in was PVC. Should never use that with distilling. Oh, that's terrible. You should never do. You know what? I have to agree with you. Yeah, that's a good comment to make. It should never be used when you're distilling, but we're not distilling, we're filtering. Let's say understand PVC. Oh gosh, I have this written up. PVC, polyvinyl chloride. All right, it's impervious and insoluble to alcohol. What does that mean? It means that it will not dissolve in alcohol. Now, keep in mind that if you do one other thing is you add heat to it, well then, you know, the boiling point for PVC is 100 degrees Celsius, 212 degrees Fahrenheit. So when you put a lot of heat to it, it gets really soft and it starts to flake off. I mean, you follow me. So no, you would never make a kettle out of PVC, nor would you use it as a column, nor would I use it as a condenser. But we're using it as a filter. So when you have a spirit that is room temperature and you're just going to use it as a filter, remember that polyvinyl chloride is insoluble to alcohol. So it just acts like nothing more than a glass jar or a PVC jar. And if you're really concerned about it, use CPVC, because the boiling point of that is 150 degrees Celsius. But unfortunately, they don't make them in really, really large size pipes, at least not readily available. We're going to put this together, and this is the fun part. And I'm going to show you how I do this. Yes, we can use paraffin wax. I use what is just normally available. I've got these little tea lamps that I snuck out of the house. The wife's got a bunch of these, and she doesn't know it's missing. I use tea lamps because it is an unscented standard white candle wax. And there's one or two things you can do. I can either light this and allow it to start to melt and make a nice little puddle, which is one method, or I can use the shortcut. It's called a heat gun. And what I don't want to make it so liquefied that it burns my fingers. I just want to make it a little bit pasty, you know, so I just want to warm it up a little bit. And then what I'm going to do, see, I've already replaced my screen. I've put the screen back in there. I still got a hole in the bottom of it because I'm going to put that mesh in there. I'm going to attach these together almost completely. Just ever so slightly. See, I'm going to put them together, but I'm going to leave a small gap there. And that gap is so that I can take a little bit of this wax and run it around there. Now, it doesn't take a whole lot of this wax. And let me just flop this around here real quick. And I'll show you this on the video because this is just so neat. And it makes this thing sealed up so that it doesn't leak, but it also makes it easy to disassemble with just the application of a little heat, and then you just clean it off when you're finished. There. So you see I've got those globs of wax laying around there. And if I heat them up, they start to melt. And as soon as they start to melt, woo, it doesn't take too much, it doesn't take too long. Then you push it together all the way and then heat it up so that that wax works its way into that crack and crevice. Ouch. This is a small piece of pipe to work on, so it does that. Give it a little tiny twist, and then that wax just settles inside that connection, and when it dries, it becomes real stiff. And also, it becomes watertight. Now, it won't withstand a lot of pressure, but then again, how much pressure are you... Please don't put any pressure inside your filter. Remember, we want to control the flow out of what we call the business end. So we're going to do our best to restrict the flow. And if we added pressure to it, what would we be doing? We would be increasing the flow. Because contact time with our carbon is an important function. Now, hey, while I'm getting ready to do the rest of this, let me show you, watch this real quick. It's just a couple of minutes, but it does go into a little bit more detail. So some of you may want to shoot through this part if you really don't care. Well, in the interest of full disclosure, first of all, I got this photograph or this illustration from a book written by a guy named Gert Strand. He has produced an internet version of a periodical that is really good for home distillers if you're really interested in the idiosyncrasies and all those things about filtering and carbons. It really does a great job of explaining everything in such detail that you have to read it 2 or 3 times. But it's a really good publication. It's 28 pages long, and it's really helpful. So you can find it. Just type in Gert Strand in your search bar, and that will lead you to his publication. Now, even Brewhouse posts it on their website because it's such a good publication. But this is a picture of a piece of stone carbon. And what I want to try to illustrate here is exactly how does carbon work and what does it do and why is it so effective? Well, stop it. Look, these things are either chemically or physically pulverized or activated and then pulverized into small pieces, which leaves a whole lot of cracks and crevices they call pores. You have macropores, you've got, of course, mesopores, and then you got micropores. And now this is an example of why you need to understand that all carbons are not created equal. You know, some you have peat carbon that is really chock full of a whole bunch of micropores, does a really good job, but unfortunately it's not that easy to regenerate. So we're kind of looking for, you know, sort of like a balance between macro, meso, and micros because they all serve a useful purpose. And the stone carbon is, you can regenerate over and over again with a little bit of caution and care taken in doing that. So, how does this actually work? Well, what actually happens is I like to say that when I ask a question, well, what was this? Well, let me tell you what happened was, I know you're going down the wrong road. You know what I mean? All right. Let me get a smaller pen size here. And if we start off, we say we've got a small molecule, okay? These pore sizes are designed for specific purpose, and we have a really small molecule here. Of course, there are going to be billions of them, but this molecule starts to make its way towards your piece of activated carbon. All right, and if it's small enough, it will slide into one of these pores, and it gets lodged in here. Now, what type of a molecule would do that? Well, your smaller molecules, which happen to be your more volatile substances with a lower boiling point that have carried over into your distillate. You see where that's going, yeah? And let's say, for instance, in comparison, an ethanol water molecule is going to be much larger. So this, of course, will not fit in there, and it will not fit into one of these micro slots, so it just continues on past that piece of carbon. Whereas all of these smaller molecules that tend to show up in your distillate start to fill in these voids and therefore are absent on the other end. Now, when you see how simply that works, very, very similar to the molecular sieves that we used when we were trying to remove water. But in that particular case, we were separating a water molecule and an ethanol molecule. And we just wanted to leave the ethanol molecule behind because it's just a little bit larger than a water molecule. So you see how this actually works. This is really fascinating science, and it's a really, really deep topic. Matter of fact, it probably has its own separate scientific community that's about the size of what activated carbon does. Let me show you something else. There. Now I drew that out. I stopped and drew that so you didn't have to go through the problem watching me do that. Now we've got. We already know that we have, of course, foreshots, heads, hearts, and tails. All right. What do the hearts contain? Our hearts that's where our ethanol is. And we know the chemical formula for ethanol is C2H5OH. Okay, and I throw that in there for those of you who want to really, really geek out on this, because there's just so much there to know, and it really opens up your full understanding of what's happening, what's taking place. And you know the boiling point for that is what? 173.1 degrees Fahrenheit, or what is 78.37 degrees Celsius. It depends on which textbook you look at. I always say that because I've gotten different figures, but it's somewhere in that general area. All right. Here's what we do know. We know that there are like oodles and oodles of alcohols. You just can't count them all. But primarily, it boils down to just really a basic few in the distillation community that we need to be familiar with, or that we are associated with and need to be on the lookout for. And those are the ones in our foreshots and heads. Now remember, there are portions of heads, you see those flavor profiles that may be resident in those heads that some people like to transfer and smear across all their batch because they're kind of looking for that. But at the minute levels that they're not as dangerous as they would be in their pure form. Now those include methanol. We're already familiar with methanol. Look, the boiling point is 148 degrees Fahrenheit, 65 degrees Celsius. What does that make it? It makes it a highly volatile, low boiling point alcohol. That's why it comes off first. You see, you can't stop it. You can't hold it off. It's just going to happen. We have acetone. Same thing, 133 degrees or 56 degrees Celsius. And then, of course, acetaldehyde. That comes off at 68 degrees Fahrenheit or 20 degrees Celsius, so that happens quickly too. Now, these are minute, but taken together, they do constitute a good portion of your foreshots and heads, which makes them undesirable. Because remember that they are low boiling point, and they are very volatile. Now, do we absolutely get every one of those? No. You know that, and I know that. It's impossible, and there are some studies that would indicate that there is a minute amount of methanol left in mixed in with the tails because of the molecular structure and then the attractive forces, and there's a lot of things going on. But for sake of argument and for the simplicity of the distilling community, if we remove those foreshots and heads, well then what we have left at that point is our ethanol. This is what we're looking for. Now let's go on to tails, because this is what became strikingly interesting. The more I delved into it, the more I learned about this. Look, we have butanol. There we go. Butanol, 1-propanol, and amyl alcohols. And these, matter of fact, the amyl alcohol and a few other things fall into like the fusel oils. Look at the boiling points of these. 243 degrees Fahrenheit, 117 Celsius, 206 degrees Fahrenheit, and 280 degrees Fahrenheit. These are very high boiling point. Yeah, my handwriting's terrible. So we got a very, very high boiling point, so they're not as volatile as the other substances. That's why they show up last, and that is with an extreme amount of heat placed on your system. Now, can they come out early? Absolutely. Remember, we talked about all of those things that take place in the still in the first place, and then you've got all of these connections and all this activity that's going on. Yes, with an extreme amount of heat, you can push out some of these alcohols. These are undesirables, and we know that they're undesirables. They're not as miscible in alcohol because they show up cloudy. We know that they can have a really off odor to them. They do have a very pungent, nasty flavor to them, and they also can be a little bit oily and slicky between your fingers. So those are the things that we don't want. Now, you just stop and consider if we look at, why did I put the chemical formulas up here? The chemical formulas are indicators of molecular size in a way, okay? Not all things are not equal, but within reason, within reason, a chemical formula almost kind of indicates in a way a molecular size as well. If you look at the molecular or the chemical formula for these with the size of those molecules, here's 5 carbons, 12 hydrogens and an oxygen, 3 carbons, 8 hydrogen and an oxygen, 4 carbons, 10 hydrogen and an oxygen. And if we compare those in size relative to each other, we have these larger size molecules as opposed to our ethanol molecule, as opposed to our, the methanol, acetone, acetaldehyde, which are really small. What happens to this one when it passes by a piece of carbon? Well, it doesn't fit into any of these, so it just continues to go by. So that explains why the filtration of tails is not a good idea, nor is it a very effective method for removing the tails, because your tail molecules and your fusel oils are molecularly larger than all of your others. So, and I know it. I've had the comments, and I've had people write in, I filtered my tails and it came out tasting great. Well, all I can offer is it probably wasn't tails, but okay. I'm not going to argue with you about it. I know what works, and I know what is, and what isn't. That's all I can offer you. I hope you enjoyed this portion. Now let's get back to the video, and let me show you what, as we get this thing put together, and we just prepare for a use. Well, I hope you found that as interesting and educational as I did. I'll tell you what, I learned so much through that research process, because there's just so much to understand. You see, every time we open a door in this hobby, we learn so much more, and it is applicable to just about everything that we do, especially within this hobby. So I was really interested to find out why filtering tails was not as effective as you might think it would be. That was just astounding to me. Okay, here's what I did while you were watching that. I put this together, so I've got it all waxed together. That's dried, so it's nice and sealed. And I put a small tube on the end of the business end. Yeah, and I ran that tube up the side, and I just taped it to the side here. So what's that going? That's sort of like a level indicator, but I'll never be able to put more water than this tube is up here, or else it would come out. I'm not going to put that much water in there, but I am going to fill this with water, and I didn't want it to run out while I was filling it up. So, yeah, because what's going to happen is that we're going to prepare our carbon. Now, if remember I told you about that on that video, what we did with the whiteboard, I told you go to Gert Strand and download that ebook. Matter of fact, I'll think of it. I'll actually put it in the descriptive portion of this video, a direct link to it. It's an excellent periodical. It's like 28 pages, but it's just chock full of information if you want to regenerate, using a couple of different methods, if you want to increase the effectiveness of your carbon. And he really does a great job of explaining a lot about carbon in itself in general. Although it is a little biased because I think he runs the company for Prestige. He's out of Sweden, but it's a great read, and it's full of a lot of information that I've been able to verify through other sources. So it's not, you know what I mean. It's not just a periodical written as an advertisement. It's chock full of a lot of great information. Okay, I've already poured my activated carbon into my pot here, and I'm going to use distilled water. Now, why would I use distilled water? Or in this particular case, this is agua destilada. I'm multilingual, I guess. I've got distilled water for a reason. Now, because, you know, distilled water has been distilled, so all of those minerals, deposits, and all that other stuff is no longer there. So it should be just kind of like pure water. You could use filtered water. You could use regular water, because what you're going to do to it is you're going to heat it up, and you're going to bring it to about a boil and let that sit for just a little while. And that will remove some of those impurities that you're trying to get rid of anyway, except for those that settle in the bottom. So the cleaner the water you start with, the better off you're going to be. But regular tap water would work. But if you have an option, I think there's like 88 cents a gallon. Or you got to still run some water through it. Distill some water. Man, make yourself some pure distilled water. So I've got that in there, and I'm just going to pour a heaping amount, which is, according to that periodical, it's like twice the amount of water goes into this. And what I'm going to do this like 3 times. Probably a little bit of an overkill, but this is one of those cases where a little bit more is better than not at all. I'm going to heat this up on my New Wave once I plug that in, because I forgot to do it. I'll get that going right now while I'm talking. I'm going to bring that up to a boil, and then once that boils, then I'm going to turn it off, and I'm going to pour off the water, and I'm going to redo it again. And after the 3rd time, what I should have left once I pour the water off is a prepared substance of my activated carbon, stone carbon, that I'm going to put inside my tube. And right prior to doing that, I'll fill this tube up with water, and that water is only there to receive that and allow it to settle and pack in place in preparation for use. Now, as this starts to heat up, you know, that point about talking too much, I get those comments as well, and I'm sorry. I just think a lot of times as we're doing videos, I think about guys like Mike down in Florida. You know, his handle's the Blind Pig. You know, Mike is a blind distiller, and yes, he's a subscriber and an avid watcher or listener to our video series. So sometimes I consider that not everybody who is an avid consumer of our videos is able to see. So forgive me if I get a little bit verbose and try to describe something that to most of us comes across as pretty direct. We can see it. There are those who cannot see. So I'll offer that to you. Have you noticed how many advertisements are on YouTube? This is not going to take long at all. I'm sorry, I can't control that. I've looked, and I keep trying. Look, one way of thinking about it is if this channel wasn't so successful, maybe they wouldn't take advantage of us and put so many videos on. But I understand. I hope that it's not too overwhelming And if you see them, trust me, I'm a subscriber to hundreds of channels as well, and I'm a consumer as well as a video producer. So I do understand, and yes, it is troublesome. I've noticed it as well. I'll be back after, when I get on the third one, I'll come back and we'll do the rest of this. Okay, I've been to my third boil now. I'm going to add water to this, and I'm only going to add about a half a liter because the remaining on my third, see, and this is also going to verify or validate whether this thing it's sealed. I'm going to use the remaining water that's already in here. I'll pour some of it out, and I'll add some cold water so that I can get a slurry of my carbon that goes in there. But it kind of begs the question, and I know it's going to come up. Why? Why on earth do we actually boil the carbon in water a couple of times before we put it in here to use it? And that's because, you know, in God we trust, all others pay cash. You've heard that. You know, I do know that this is a quality product, but during the manufacturing process, you know, if I want to get it to work at 100% of its effectiveness or its capability, you know, I'm not sure what byproducts are left in here. Whether this was the beginning of the batch, the middle of the batch, the end of the batch, was it the stuff off the bottom? I don't know that. I do know that I can rest assured that this is a 20 by 50 mesh size, and I do know that it's activated stone carbon. So some of those impurities, and you'll notice that when you do, even I can still see just a slight amount on the surface of this, but and you may not be able to detect that, but there are some very slight impurities that they're just residual, and they're there just because they're there. And we can remove those, and that makes it just that much more effective. So what I'm going to do is I'm going to pour out a little bit of that. I got to find something to pour it into, and I shall return. Now, this will be just a little bit messy, so you can scrape it out with a spoon. But you'll also find that as you're trying to sieve out that, you know, pour off that excess water, that if you just do it slowly and carefully, that all of your carbon will sink to the bottom, and you can pour off all of that surface water. So my next step, the only thing I've got left to do after this is to pour some more water through my filter, and then, of course, drain off all of that water prior to using the filter. Yep. That's as good as she gets. Now, once I've got that in there, of course, holy shit, that thing fell apart. Should have supported that just a little bit better, and my wax didn't hold as nicely as I wanted it to. Oh man, that didn't happen. That's the first time that's happened to me. So, well, you've seen the trials and tribulations, you know. Shit, I guess shit happens. So there's all my activated carbon, not all of it, but a good majority of it. All over the place. And I'm back to the drawing board. So not to worry. We'll get back and do this again, but you kind of get the idea. Now we do know that you can use PVC. I need to do a little bit better job of sealing those connections. We understand how activated stone carbon works. We know where it's most effective. We know where it's not as efficient or effective, that being in tails. And we kind of know that we don't have to do all of our spirit. It's just those spirits that we're just trying to become neutral in. Man, I actually had a thought I was going to cut that out, and I was like, no, I'm going to leave that in because, yep, it happens. Happy distilling.